Hi guys. So the last section of Module 8 is 8.4, which covers the fifth and final special segments of triangles. They're called midsegments. So we'll use the midsegment theorem to solve for segment lengths in a triangle, and then we'll also prove some properties that midsegments have. A midsegment is a line segment that connects the midpoints of two sides of a triangle. So here, D is the midpoint of side AB, E is the midpoint of side AC. If we connect those midpoints, we get this segment DE. That's the midsegment. And we can draw two more midsegments if we wanted to. If we had the midpoint of this side here, we could draw one midsegment connecting those two midpoints and then a third midsegment connecting those 2 points. So every triangle has 3 midsegments. There's no center with the midsegments. You guys can see that these 3 segments do not intersect at the same point. They're not concurrent lines, so midsegments do not have a center like the other segments we've been talking about. They do have 2 properties though. So one property is that the midsegment is parallel to the third side. So DE is going to be parallel to the side it doesn't touch, BC. So DE is parallel to BC. That's one property that midsegments have. The other property is that the midsegment is half the length of that side. So the length of DE is half as big as the length of BC. That's the other property. Those two are parallel and DE is half as big. So we're going to do 3 examples. The first example, we're going to show that those properties are true. So we have a triangle here. P is the midpoint of LM, so this top side, and Q is the midpoint of MN, so this right side. Let's go ahead and find those midpoints. So we did this back in Module 1, finding midpoints. P is the midpoint of LM. L is at 2, 7, and M is at 10, 9. So remember, to find a midpoint, we add our x's together, so 2 plus 10 divided by 2, and we add our y's together, 7 plus 9 divided by 2. So that gives us 12 over 2, which is 6, and then 16 over 2, which is 8. So this midpoint should be at 6, 8, which looks correct. So that's point P. Okay, we'll do the same for the other midpoint, Q. So that's the midpoint of MN. Point N is at 8, 1. So we'll average the x's, 10 and 8. And we'll average the y's, 9 and 1. So 18 over 2, that gives us 9, and then 10 over 2, that gives us 5. So 9, 5, which again, that looks like the midpoint, so that's point Q. And then we can go ahead and draw our midsegment. There it is. Okay, so let's show that first property. Let's show that PQ is parallel to LN. The way we can do that is using slopes. Parallel lines should have the same slope in the coordinate plane. So if we look at the slope of PQ, from P to Q we go down 3 over 3. And down 3 over 3 simplifies to be -1. So the slope of line PQ is -1. We'll do the same thing with LN. We can see here we go down 1, 2, 3, 4, 5, 6 over 6. So down 6 over 6 also gives us a slope of 1/2. So since these two slopes are the same, we can go ahead and say that those 2 segments are parallel to one another. All right. The other property is that PQ is half the length of LN. So to do this, we need to either use distance formula or Pythagorean theorem. I'm going to use Pythagorean theorem to find the length of segment PQ. So I'm going to go ahead and draw my right triangle. This right triangle has side lengths 3 and 3. So 3 squared plus 3 squared is equal to the length of PQ squared. We get 9 and 9. So that gives us the square root of 18. Let's simplify the square root of 18. 18 breaks down into 9 and 2, and 9 breaks down into 3 and 3. We have a pair of 3's, so that means we can bring a 3 outside, and then we have a 2 with no pair, so that guy stays inside. So root 18 is the same as 3 root 2. Okay, now we just have to find the length of ln and show that it's twice as big. So this right triangle has side lengths 6 and 6. So 6 squared plus 6 squared should be equal to the length of ln squared. We get 36 and 36. Add those together and take the square root, we get root 72. And 72 breaks down into 36 and 2. 36 breaks down into 6 and 6. That breaks down into 3 and 3. Oh, sorry, whoops, 3 and 2, 3 and 2. So you can see we have a pair of 3's and a pair of 2's, and then we have 1, 2 left over. So our pair of 3's, we can take a 3 out. Our pair of 2's, we can take a 2 out. We have a 2 left over. That gives us 6 root 2. So you can see here, if PQ is 3 root 2 and LN is 6 root 2, that shows that LN is twice as big as PQ. All right, for the next example, we have triangle RST, and we have 2 different midsegments drawn. We have midsegment UV, which has a length of 5.6, and then we have midsegment UW. We know this side of our triangle ST is 10.2, and then we're given this angle is 41 degrees. So let's find UW. That's this segment right here. So remember, the mid segment is half as big as the side. So if the side it's parallel to is 10.2, that means UW has to be half of that, which is 5.1. Next up, we're finding the measure of angle SVU. That's this angle right here. And remember, these two sides are parallel to one another. So we can go back to Module 4, think of parallel lines and transversals. 41 degrees, this one's also 41 degrees because those guys are alternate interior angles. RW is this guy right here. Remember, midsegments are made with midpoints, so we know W is a midpoint, which means those two guys are equal. We know this midsegment is 5.6, which means the whole thing's 11.2. So each of these little pieces has to be 5.6 as well. Last, we have the measure of angle UVT, which is this angle right here. And this is a linear pair with this 41 degrees. Linear pairs we know add up to be 180, so we can find UVT by doing 180 degrees minus 41 degrees, which gives us 139 degrees. All right, the last example, we're going to solve for the value of n. We know midsegments are half as big as the side they're parallel to. So n plus 12 has to be half as big as the side it's parallel to. Half of 6n is 3n. If we subtract n from both sides, we get 12 is equal to 2n, so that means n has to be 6. And if we plug it back in just to double check, we get 6 times 6, which is 36, and then we get 6 plus 12, which is 18. So you guys can see 18 is half as big as 36. We know we solved it correctly. All right, that's the end of midsegments. So you guys can work on your 8.4 homework on HMH, and then there is a Module 8 review worksheet for you to prepare for your quiz on Friday.